Hello and welcome everybody. Today is the 21st day of our Smart 25 Days challenge, and today we are going to make a salary distribution smart contract. So, as I told you in the previous video itself, that we would be working on something like this. So, this is it. Let's start making a salary distribution smart contract, which by the name itself explains that this smart contract would be made specifically for the distribution of salaries of the employees and distribution. Okay, so what we are going to do is simply we would be making a owner, and that owner we would be allowing giving some specific permissions to that owner. So he would be responsible for adding the employees to his organization. He would be able to manage the employees. He can remove them, he can update their salaries, he can and most importantly, as this smart contract is about salary distribution, so he can distribute their salaries. So that's what we are going to make and do in this smart contract. Apart from this, we would also be discussing about fallback functions, and that's all for the smart contract. And let's get started. So first of all, let's just start by declaring the version. Okay, looks cool. An XPDX license identifier, MIT. Yes, okay. Now contract. Let's call it salary distribution only. Distribution. Okay. So now, first of all, let's declare the state variables. That would be first one is owner. Okay. And the state variable for this is owner itself, owner only. And apart from this, we would be using a mapping is which would be used to associate the addresses with the units for what for keeping the salaries of the employees, and we would be keeping it public. Okay, to increase transparency, so that okay. And apart from this, what we want to keep the addresses of employees in an array, and the type of arrays of address data type public called as employees. Okay, looks fine. So now we would be making a modifier so that we may not need to write the code again and again. Okay, a specific piece of code. Yeah, yes, again and again only. Uh, and if you guys are facing any problem, or if you are not able to understand what I am doing, or you are not comfortable, so please go through my previous videos where I have explained each and everything in detail. So you can watch that, and otherwise just keep following. So we are making the modifier that for the owner only, called as only owner, and we would say the error message would be only the owner can perform this action. Okay, so then just full stop and cool, and just r underscore good. So okay, so that's it for the modifier. Let's now move forward with the constructor. Constructor, special type of function which is just executed one time while the deployment of the contract. This is dot sender. Okay, so this constructor is this much only, and then now let's move and start making the functions. The first function would be to add the employees, add employee only, and the parameters it would take are address, employee address, and then salary, employee address, and unit salary. So I have told you in previous videos also, UN 256 and UN are the same thing. You can use either of them, but many people you prefer UN 256, writing UN 256 to specify it clearly. Depends on you. Now let's just okay, for adding the employee, let's push the address of the employee into the employees this array. Okay, employees array, and employees. Okay, then employees dot push. Okay, and push employee address. Okay, fine. And then in the salaries mapping by using the key employee address, assign the value of salary. Okay. Looks cool. Okay. Yeah, understood. I guess you all must be understanding it is pretty well. If you have followed the previous videos, then it's pretty simple. And now let's move forward to, but let me just clear it a bit. Okay, so here for the employee address, we are pushing the employee address to the employees array, and then in this mapping, in this salaries mapping, what we are doing it, this is the key. Employee address will act as the key, okay, as you can see, of data type address, and then UN 256 will get associated with it, that is the salary. Okay, so we are assigning the salary with a specific associating that salary with a specific employee address. Now let's make a function to remove the employee, and yes, okay. Uh, this it would be just taking a single parameter, that is employee address, and it should be public, but just called by the only owner. Okay, yes, looks cool. So now for removing the employee, what we would be doing it, we would be running a for loop from from 0 to I less than employees dot length, employees dot length, yes, and I plus plus. Yes. Okay, and in this, if employee, if and the employees array, you find something that I the ith index in the employees array is actually the employee address provided by us. So what you do, you just delete that. Okay, and delete employees I yes, okay, and delete from the mapping also salaries employee address. Okay, so and then break. So what's happening here is this delete is a special keyword used in Solidity, and what it will do is it will reset the value to the default value. And what is happening, what would be happening here is, so in the employees array, if the ith index matches the employee address provided by us, so that means that yes, the employee is there. So what you do, you when as soon as the match found, just you just set its value, you just resets its value. So this delete will reset that value, the value of the employee, the address is stored at the ith index in the employees array, and the default value is a zero address. Okay, something like 0x and 000 something. So it will get set to that, and similarly that will happen for this mapping. Okay, the keys would be there, but the values associated with that employee address, well, that means that the value associated with the particular employee address, that means this in this mapping, the salary, because the for a specific address we have associated a specific salary, so the salary will become zero because the default value for unit is zero only. So that's what this function is going to do for removing the employees. Okay, so this is it, looks fine. Okay, and yes, close. So now our this function is also complete. Let's now make a function to update the salaries. Update the salary. Okay, address, employee address, unit new salary, because we want to know the new salary so that we can assign that. Okay, and public only owner, because only the owner should be able to change the salary of other employees. Otherwise, this may not happen that other employees are changing the salaries of other employees. So, and then just check whether the employee is there or not. And how we are going to check that is employee address. Because if our employee is there, so their salary must be greater than 0. Okay. So yes, we are not taking the case of unpaid internships here. So, and because it's specifically related to salary distribution, so that means that if our employee is there, so his salary would be greater than 0. Otherwise, we would say that the specified address is uh, not an employee. Specified address is not an employee. That's it. And now let's just move forward. And if everything works fine, then what you do in the salaries mapping, the value, update the value associated with a particular employee address, just make it new salary. That's it. Simple as that. And that's how the salary gets updated. Okay. And now the final and the masterpiece, that is the pay employee. Okay. So a function to pay the employees. So it should be public and called by only the owner. Okay. Then, okay. So first we would be getting the total salaries. And yeah, for this we would also be making a helping function, that is to get the total salaries. Okay, so the total salaries would be able to get to the get total salary, the value received by calling this function, and we would be declaring it just afterward. Okay, yes, and check the required condition. Required condition would be address this dot balance, this then dot balance should be greater than or equal to total salaries. Yes, otherwise we'll say insufficient sufficient funds. Simple if insufficient funds. And just that's it. And if everything works fine, then just pay the employees one by one. And how we can do that? Just run a for loop for unit I equals to 0, I less than employee employees dot length, yes, and I plus plus. And then just employee address, employee address, okay. Address payable employee address should be payable employees, the value retrieved by, and from the employees mapping at the ith index. So then your salary would be salary, and from the mapping salaries, value associated with the employee's address. Okay, yes, cool. And then just employee address dot transfer. Okay, yes, transfer, and then salary. Okay. Yes, looks good. So I hope ever you must be able to understand this. So we are checking whether our balance is greater than the total salaries or not. That means that yes, there should be sufficient balance to pay each and every employee. If we are calling the pay employees function, then we would be running a for loop. That's simply running from I to the value 0 to the length of to less than the length of the employees array, which makes sense. And then we are increasing it, and this address payable employee address is what it's doing is it's storing the value or retrieved from here, because in the employees address, okay, in this array you can see in the employees array we have stored the addresses of the employees. So for each employee, okay, for each employee address and payable means that yes, this address can receive some ether, okay. So that's why we have marked this payable, marked this as payable. And then we are just what we are doing it, we are storing it, the value retrieved from, that means the address is stored in the employees array at ith position is retrieved, okay. And then it's stored into the employee address variable. And then we are calculating the salary. How we are doing that, we have declared a variable called as salary, and in that salary variable the value which is stored is retrieved from the salaries mapping by using the key employee address, this employee address which we just now used, okay. This employee address as the key, we are retrieving the associated salary, associated value from the salaries mapping and storing that into a variable called as salary. And then we are just transferring that amount to the employee's address, and we are repeating this step. So this keeps on, employee address keeps on changing and gets iterated, as you know about a for loop. So that's how we pay the employees, okay. So that's what this function is doing, and all. So after that, let's just move on to our last and the helper function, which is going to be the get total salaries function. So let's make it function and get total salaries, okay, public and view only, and called by only owner only, because we don't want anyone else to just know the complete salary of all the employees in the our company for maybe any reason, okay. For, and this will take total, and this will just return total salaries, okay. Yes, total salaries, and that's it. And just let's retrieve it. You and I to I equals to 0, I less than employees dot length, I plus plus. Then address, employee address, employees I. Then total salaries would be plus equals to salaries, the value retrieved from here, employee address. That's it. So I hope it's clear. What it's doing is we are you calling this. So what is happening is this will run a for loop from I to the value 0 to employees dot length or less than employees dot length, and then I is getting increased. And similarly, as we retrieve the value here, this here also, what we are doing, we are just retrieving the value and storing it into the employee address, and that by using that employee address as the key, and we are accessing this salaries mapping. And then we are what we are doing it, we are because this thing by accessing the salaries mapping by using the key as employee address, we would be retrieving the unit of that is the salary for each individual employee, and we are just increasing that, and we are getting the total salaries. So that's it for this function also. And now all the functions are complete. So now let's just talk about fallback functions and what are they. So in Solidity, fallback functions are used for for handling some specific use cases. Maybe is if someone tries to call a function which is not in or in the functions which are present here, and by mistakenly or by some error. So if he or she calls that function which is not here in this smart contract, so the fallback function gets executed. So in this smart contract, we would be using a special fallback function which was introduced in the Solidity version 0.6 after that, and that is called receive. Okay, so we would be using that receive, 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 and external payable. That's the basic syntax of using it. And what it will help us in doing is it will help the owner, and anyone can send the funds to this smart contract. And how it's going to do that is in a simple manner. So let's just compile and or deploy it to, so that we may check it. Okay. So as you can see, this guy is now the owner. You can see the address and yes. So he or she can just add some employees. Okay, so let's try adding some employees. This employee address and the salary says okay, this much way. And let's see what happens. Okay, so only the owner. Oh, sorry, forgot to change the account. So you can see I called the function by this account only, which should not be the case. We should call this function by the owner's account, and this proves that yes, this smart contract is working fine. And let's try to call this by owner's account. Okay, so now you can see the employee gets added, and now similarly we can add other employees also. So we will add 2 3 employees here. So, and let's make salary to be this much. Okay. Oh, sorry. This time also I forgot to change the account. And now, yes. So see, this is how we are able to add the employees and their salary in this smart contract. Let's say fire. Okay. And this time let me first change. Yes. And now, yes, so it's working fine properly. So now you can see if the owner calls this get total salary, he will get this much amount, that yes, this is the total salary of the employee which you need to pay. And now what will happen is this this owner will, what he or she will do, he will just uh, use this value and send this much amount of way into the smart contract by calling this transact. Okay, because these are low level interactions. Okay, and that's why they are not present here, these fallback functions. So now this guy can just click on this button, and you can see this much amount of ETH has been received by this smart contract, which means our payable function is working fine. And now the owner can pay the employees, and he can just click on this pay employees, and you can see the salary gets distributed successfully. So now you can see the salary gets successfully distributed to these accounts, and that's how this smart contract will work. And if you guys have any confusion or anything regarding this smart contract, then you can please reach out to me on Twitter or LinkedIn, or you can just comment the down. And I would be providing the links for some resources for this smart contract of say for the delete keyword, or for this fallback functions and receive. And so you can go through the official docs and all for better understanding, for more clarity. And that's it from my side, guys. If you guys have any doubts, then please ask it out in the comment section. We'll meet on the 22nd day of our Smart 25 Days Challenge. So, till then, bye bye.